Welcome to this explainer. Today, we're unpacking the blueprints of aviation's most beautiful paradox. We're talking about a Mach 2 marvel that absolutely conquered the skies, pushing the very limits of aerospace engineering, yet completely plummeted from an economic standpoint. If you've ever wondered how the ultimate symbol of futuristic travel ended up as a museum piece, well, you're in the exact right place. Let's get into it. 23 million pounds. That massive number? That was the staggering unit cost for just a single Concorde aircraft back in 1977. To put that into perspective for you, the development cost completely spiraled, ending up more than 6 times over the original projections. What kicked off as this ambitious joint venture between the UK and France quickly morphed into an absolute financial black hole. And that brings us to the central mystery of our explainer today. How exactly did aviation's greatest engineering triumph become its absolute biggest commercial failure? We're going to examine the structural forces, the brilliant mechanical workarounds, and, of course, the unforgiving financial realities that answered this exact question. Section 1. The Supersonic Dream. Let's see where the initial spark for supersonic commercial travel actually came from. You see, the idea of ultra-fast airborne logistics was really born out of the 1948 Berlin airlift. This massive logistical operation essentially proved to the world that aircraft could entirely bypass the sluggish pace of traditional shipping. Suddenly, replacing slow ocean liners with fleets of fast-moving cargo and passenger planes wasn't just some science fiction pipe dream. It was the logical next step in global commerce. The acceleration here was incredibly rapid. Just look at this timeline. We go from the single-seat Bell X-1 breaking the sound barrier in 1947 all the way to 1962 when the UK and France signed a full-blown joint treaty to build a commercial supersonic transport. And make no mistake, this wasn't just a corporate merger. This was a state-backed alliance driven by a fierce, undeniable desire to dominate the future of the skies. By 1969, that dream was actually in the air for its very first flight. Section 2. Engineering a Mach 2 marvel. It is time to pop the hood and look at the sheer technical audacity required to build this machine. Check out the OG plan form on this blueprint. Notice the shape of that wing? It's not your standard delta, it's compound rounded, and it's an absolute stroke of genius. At supersonic speeds, normal wings create immense drag. But a supersonic transport still has to fly slow enough to land on conventional runways, right? This highly distinct shape allowed the plane to slice efficiently through the air at Mach 2, while at low speeds, it generated powerful vortex lift right over the top of the wings, keeping the whole thing perfectly stable during approach and landing. But here's the catch. That delta wing required a super steep angle of attack during landing. I mean, so steep that the pilots literally couldn't see the runway in front of them. To fix this, engineers came up with the famous droop nose. This thing shifted seamlessly through precise angles. You've got 5 degrees down for taxiing, locked completely flat at 0 degrees to streamline the aerodynamics at supersonic speeds, and then it drops a drastic 12.5 degrees to give maximum visibility when coming in for a landing. Pure engineering elegance. Now, a crucial divergence in design philosophy was happening at exactly the same time. While European engineers were pouring their souls into Concorde, over in the US, Boeing was building the 747. Concorde prioritized blistering speed for a specialized few, roughly 100 passengers, while burning absolutely massive amounts of fuel. Competitors like the 747, on the other hand, optimized for sheer passenger volume and aerodynamic efficiency at slower, subsonic speeds. This fundamental split in design philosophy basically set the stage for Concorde's commercial struggles down the line. Let's look at the incredible tech they packed into this narrow frame. Underneath the skin, which, by the way, was made of a special aluminum alloy called hydaminium that actually stretched and expanded by up to 12 inches just from the kinetic heat of Mach 2 friction, this aircraft was a true pioneer. It featured the first commercial analog fly-by-wire controls. And even more mind-blowing, because the center of aerodynamic pressure shifts backward at supersonic speeds, engineers built a system that actively pumped fuel from the front tanks to the rear tanks mid-flight. They literally used the fuel itself to rebalance the plane's center of gravity on the fly without causing any extra drag. Just brilliant. Section 3. The sonic boom backlash. But as we know, the very physics that made Concorde an engineering triumph also triggered its first major roadblock. Speed definitely comes with consequences. Pushing through the sound barrier doesn't just create a single click pop. Oh no, it generates a continuous sonic boom that drags right along the ground for the entire time the aircraft is flying supersonic. The noise was literally so explosive that residents below compared it to a bomb going off. Naturally, this sparked fierce environmental pushback. Suddenly, entire nations started banning the Concorde from flying at supersonic speeds anywhere over their land. And then a perfect storm of external shocks hit exactly when Concorde was trying to sell planes. In 1971, the U.S. canceled its own supersonic transport program and banned those overland supersonic flights we just talked about. Then, the 1973 oil crisis sent global fuel prices straight to the moon. And finally, the tragic crash of the competing Soviet supersonic plane, the Tu-144, at the 1973 Paris Air Show absolutely terrified prospective airline buyers. Section 4. A commercial catastrophe. All these geopolitical and environmental constraints slammed directly into the project's incredibly fragile economics. The technological marvel was suddenly looking like a massive financial liability. And as a result, the initial order book completely collapsed, despite having over 70 options from major airlines worldwide. Carriers like Pan Am, TWA, and Qantas all canceled in 1973. In the end, out of dozens of global options, only the state-backed carriers, British Airways and Air France, actually took delivery. That left a total production run of just 14 commercial aircraft. The real reason airlines fled comes down to this number right here, a dismal 15.8 passenger miles per gallon. That's what Concorde achieved with a completely full load of passengers. Compare that to a massive 46.4 passenger miles per gallon achieved by the new Boeing 747. In the middle of a global oil crisis, an aircraft that guzzled fuel at this rate for so few passengers just made zero economic sense to a commercial airline. To offset that terrible fuel efficiency and the sky-high intensive maintenance required after every single flight, ticket prices became completely astronomical. While a standard subsonic transatlantic flight was around $500, a seat on the Concorde was often $4,000 or more. We're talking about a plane ticket that frequently cost as much as a brand new car. It forced the Concorde into a hyper-niche market of executives and celebrities rather than the mass-market aviation revolution it was originally designed to be. Section 5. The Final Flight. Despite operating as a highly exclusive luxury service for decades, a single freak incident would eventually ground the fleet forever, closing the book on supersonic transport. In July of 2000, Air France Flight 4590 suffered a devastating accident chain. It started when a piece of metal dropped by a preceding DC-10 just sat there on the runway. The Concorde, moving at blistering speed for takeoff, struck the metal, which caused a tire to violently burst. Massive chunks of rubber essentially acted like shrapnel, striking the underside of the wing and sending a shock wave that ruptured the fuel tank. A catastrophic fire ignited immediately, dooming the aircraft in mere minutes. It's a really sobering reality. Until that afternoon in July 2000, Concorde had exactly 0 passenger fatalities. Technically speaking, it was one of the safest airplanes in the sky. But the psychological damage of this highly visible crash, which was broadcast all around the world, completely shattered whatever consumer confidence remained in the aging fleet. The fleet was quickly grounded and heavily modified with Kevlar-lined fuel tanks and burst-resistant tires. But when they finally returned to the skies in November 2001, they entered a completely altered world. The post-9/11 travel slump absolutely destroyed the premium corporate travel market. And then, Airbus announced they would stop supplying replacement parts altogether. The impossible maintenance costs finally forced British Airways and Air France to retire the fleet for good in October 2003. As Captain John Hutchinson put it, the aeroplane handled beautifully and remains entirely unique. Concorde really stands as a profound paradox in human history. It was an absolute masterpiece of aerospace engineering, a vehicle that conquered the sound barrier, optimized high-altitude physics, and captured the imagination of the entire world. Yet, it fundamentally failed the ultimate test of market economics. Thank you so much for joining this explainer. As we look back at the incredible blueprints of the Concorde, it leaves us with a lingering question. Is the supersonic dream officially dead, or is it simply resting, waiting for a new generation of engineers to discover the right economic blueprint? Let us know what you think, and we'll see you in the next explainer.